Hi, I'm Chengyuan Xu, and along with my co-authors, Kuo-Chin Lien and Tobias Höllerer, we're excited to present to you some highlights of our work, comparing zealous and restrained AI recommendations in a real-world human-AI collaboration task. Systems powered by AI have achieved human-level performance in some domains, but we still can't trust fully autonomous AI in high-stakes tasks. So forming a human-AI team is a great strategy to achieve complementary team performance, where the combined team performance surpasses what either the AI or the human could achieve individually. Take video anonymization, for example. We need to first locate and then blur every human face in each frame to protect people's identities. Detection model can do it quickly, but missing one face in one frame could reveal the person's identity. It is also too time-consuming for humans to annotate from scratch. This is a perfect scenario for human-AI collaboration. In this work, we conducted a large-scale user study to investigate the potential of leveraging the trade-off between precision and recall in AI recommendations to harness the complementary strengths of humans and AI, with the goal of improving human-AI team performance in realistic settings. To do this, we propose a high-recall, zealous AI and a high-precision, restrained AI for the face annotation task. We evaluated the two AI-powered tools with 78 professional annotators. We also learned how prior human-AI collaboration experience can affect user skills, should they lose access to AI in the future. So how will the two AIs perform in a real-world annotation task? The zealous AI, which would prioritize recall, will suggest more detections, even the low-confidence ones, to avoid missing any real faces. Higher recall in this task means a higher percentage of all faces in the scene correctly detected and anonymized, minimizing the number of missed faces, or the so-called false negatives. In a collaboration, a user reviewing zealous AI recommendations should see more correctly annotated faces, but they will also have to reject more false positives. On the other hand, a restrained AI with the same F1 performance would prioritize precision by suggesting only high-confidence detections, allowing user to focus on adding missing boxes without too much noise from areas incorrectly identified as faces. Higher precision means a higher percentage of correctly identified faces out of all instances identified as faces. While the zealous AI should intuitively help annotators achieve higher recall, we need to verify this in a real-world study. We also need to evaluate effect on task completion time as an important performance metric. Longer task times for humans can also lead to a decline in quality. We integrated face detection and object tracking algorithms into existing annotation tools to build an AI-assisted video annotation workflow for our user study. The AI-powered system can pre-annotate the videos, illustrated here by the green or orange bounding boxes. So the human annotators only need to reveal the AI's recommendations while maintaining control over annotation quality. If the AI accurately suggests faces, as shown here with track ID 1 and ID 4, the user can accept them without further actions to enhance the overall recall. For false positive detections such as track ID 2, the user can reject the entire track with just a couple of clicks, boosting precision. However, for false negative or flawed detections, annotators must draw new bounding boxes and track them across frames, which improved both precision and recall, but is much more time-consuming. By breaking down the complex workflow into fundamental user actions of accept, reject, and solve, and linking them to precision and recall, we found that recall is not only more important in this task, but also more costly to improve. This observation reveals an optimization opportunity by delegating more solve actions to AI. Furthermore, the human natural ability to locate faces requires no special training, make face annotation an ideal task for examining the influence of diverse AI recommendations. We designed a real-world study that ultimately spanned 4 weeks. In part 1 of the 2-part study, the 3 treatment groups annotated the same 24 videos using different methods, by working with no AI assistants or by partnering with their restrained or zealous AI teammates. We're also curious if prior collaboration experience with different AI teammates can affect users' skills, should they lose access to AI assistance in the future. So after participants worked on part 1 for 2 to 3 weeks, we removed AI assistance for everyone in part 2 of the study. We considered video difficulty and user expertise as additional factors. We curated 36 egocentric videos from the Ego40 dataset and divided them into easy, medium, and hard videos based on the number of faces per frame. Let's look at some result highlights. Here we plot the face detection recall for the over 2,000 annotated video clips as a data point each to compare the recall distribution of the 3 methods. In part 1 of the study, both Zealous and Restrained AI helped workers deliver higher recall annotations than the human-only group, particularly in medium and hard videos. As expected, the group reviewing Zealous AI recommendations achieved the highest recall. When comparing the task completion times, both AI-assisted groups finished faster than the human-only group. Particularly, the Restrained AI group also achieved significantly shorter time than the group who worked with the Restrained AI. For medium and hard videos where there are multiple faces in each frame, Zealous AI recommendations were particularly effective in reducing completion time. In terms of user expertise, both novice and veteran annotators were consistently faster with Zealous AI than the human-only baseline, while we did not observe benefits of the Restrained AI for novice users. In part 2 of the study, when no one has access to AI assistance anymore, annotators that trained with the Zealous AI continue to deliver higher recall compared to workers who previously worked with the Restrained AI. Annotators who previously worked with the Zealous AI now complete tasks as quickly as the baseline group workers who used the manual method in both parts of the study. However, those trained with the Restrained AI are now significantly slower, with novice users being the most affected. Please see our paper for full results and analysis. To summarize, in this work, we explored the precision recall trade-off in model tuning as a new direction to improve human-AI team performance in realistic settings. We proposed the concept of restrained and zealous AIs for high precision and high recall recommendations. Our study serves as a new real-world example of complementary team performance. The Zealous AI helps annotators achieve significantly better performance in the recall-demanding video annotation task. Our follow-up study observed that naively pairing humans with AI without optimizing for the task or human-AI workflow can lead to negative training effects. We hope our findings can help the design of future AI assistants. The key to improving human-AI collaboration performance is identifying and harnessing the complementary strengths of human and AI teammates through a thorough task analysis. We'd love to see more HCI and AI researchers conduct latitudinal studies in multiple recall or precision-demanding tasks to test and refine our findings. We hope our study on the precision recall trade-off inspires researchers to further map the property space for machine learning models to complement human skills. Thank you.